Lesson 5-1, Operations with Polynomials. So by the time we're done with this lesson, we should be able to multiply, divide, and simplify expressions with powers, as well as add, subtract, and multiply polynomials. Okay. So to start with, we're going to talk about the simplifying with power rules. So when we're talking about simplifying with a power rule, we want to have powers without parentheses and no negative exponents. Okay. So I have a table set up with the different rules. So we're going to talk about the general rule and then do an example of it. Okay. So if we have the product of powers, we are going to be adding the exponents. Now we have to be careful because in order to add exponents, they have to have the same base. So when we're talking about the power in the base, so if I have x to the a power, the x is the base, a is your power. Okay. Even with numbers, so let's say I had like 3 squared, the base is 3, 2 is your power. Okay. So anytime we're simplifying, our base has to be the same, otherwise we're not allowed to simplify. Okay. So again, if we're multiplying, the power is telling us how many of whatever our base is. So that means that we would just add them all together. So we're going to add our exponents. So this would become x to the a plus b. So again, if I had x squared times x cubed, we would just add those exponents together. So we would end up with x to the 5th. So the quotient of powers, so when we are dividing with the same base, we're going to subtract the exponents. And it's always the numerator minus the denominator. So this would simplify to be x to the a minus b. Okay. So again, let's say that we had x to the 7th divided by x to the 5th. I would take 7 minus 5, and that would give us x squared. Now sometimes what happens is if these are flipped around, so if we had x to the 5th divided by x to the 7th, this would become x to the negative 2. Well, this isn't considered simplified. So then we would have to go through and apply the negative exponent rule. So if we have something to the negative exponent, that's telling us to move it to the opposite side of our fraction. So we would put this over 1, and we would move that entire term down to the denominator. So this would simplify to be 1 over x to the positive a. And the reverse is true. So if we have a negative in the denominator for our power, we would move that up to the numerator. So this would simplify to be x to the positive a. Okay, so if we go back to this example, again, if I have x to the negative 2, when we simplify, we would make our own fraction. We're going to move that entire term down to the denominator. So this would become 1 over x to the positive 2. Okay. And if you have more than 1, okay, so let's say we had x to the negative 3y divided by z to the negative 2. So again, we're not allowed to have negative exponents. So we move the ones that are negative, and their powers become positive after we move them. So this would simplify down to the denominator. The z would go up to the numerator, and your y would stay the same. So our simplified answer to this would be y, z to the positive 2 over x to the positive 3. All right, so to continue, the power of a power, okay, so when I have a power to a power, we're going to multiply the exponents together. So this would be the same as x to the a times b. So again, let's say we had x squared to the 3rd power. We would take 2 times 3, and that would give us x to the 6th power. Now if we have a power of a product, okay, when there's no plus or minus, so if this is a monomial, then we're distributing the power to each term. So this would simplify to be x to the a times y to the a. So again, let's say that we had 2x squared y to the third power. So again, this is a monomial because there's no pluses or minuses in it. We take each piece and we would cube it. So 2 cubed would be 8. X squared cubed, so we're multiplying those powers together. So 2 times 3 would be 6. So this is x to the 6th. And then y cubed is just y cubed. But again, you have to be careful. You can't confuse that when it's a binomial. So if I have x minus 2 squared, you can't distribute that power into each because there's that minus in front. So again, this really means that we would have x minus 2 times x minus 2. So this, to continue simplifying, we would need to FOIL. So if it's a monomial term, you're distributing the power into each piece. If it's bigger than that, so a binomial, trinomial, any polynomial that's higher, you have to write this group the same number of times as this power, and then you're using either FOIL or distribute to simplify that together. So make sure that you're paying attention to that. That's a very common mistake when you start simplifying with these. The next one, the power of a quotient. So just like up here, if we have a divide, again, this only works if it's a monomial divided by a monomial. Okay? We're distributing that power into each. So this would become x to the a divided by y to the a. Okay? And if it's negative, so again, we would distribute. So this would be x to the negative a divided by y to the negative a. But again, we're not allowed to have a negative exponent. So we are going to move x to the denominator, y up to the numerator. So this would simplify to be y to the positive a divided by x to the positive a. Now, as kind of a shortcut, to make this power positive, you can just flip your numerator and denominator around. So again, if we do an example here, so let's say we had 2x divided by y squared to the third power. Okay, so again, we have a monomial, so we can just distribute that 3 into each piece. So 2 cubed would be 8. Then that would become x cubed. 2 times 3 is 6, so y to the 6th in the denominator. And again, let's say we had 2x y squared to the negative 3. Okay. So to start with, I'm actually going to flip my numerator and denominator. So I'm going to rewrite it as y squared over 2x, now to the positive 3, and then we would distribute. So we would have y to the 6th power over 8 times x to the 3rd power, and that would be our final simplified answer. And then anything to the 0 power is always 1. Okay. And the reason for that, so if we use our quotient rule, so let's say I have x squared divided by x squared, we know that something divided by itself is always 1. But if we apply our subtraction rule that we learned at the beginning, okay, so this rule up here where we subtract the exponents, 2 minus 2 would give us 0. So x to the 0 is how it would simplify, and then we would write that as 1. So when you're taking something to the 0 power, that's asking you to divide that term by itself. Okay? So whether it's a number, so if we have 2 to the 0, that would be 2, even a variable. So y to the 0 is going to be, oops, sorry, this is a 1. So 2 to the 0 is 1, not 2. Y to the 0 is 1. The only thing that you have to be careful of are the signs. So if we had negative 2 to the 0 power, this really means negative 1 times 2 to the 0. So we have to follow the order of operations. So 2 to the 0 is 1. Then we would multiply it by our negative 1. So this would simplify to be negative 1. Now, if the negative is inside a parenthesis, so let's say I had parenthesis negative 2 to the 0 power, then this would simplify to be a positive 1. So you just have to make sure that you're paying attention to your signs and where they're at in relation to parentheses when you're dealing with powers. Okay. In the next video, we'll do some more examples.